Alright, what we want to look at in this example is we actually want to now assume that we have some kind of pulley attached to the end of the cable. We have some type of block here, and we have a string attached to the block over the pulley, and then we have some mass, we call this mass 1 attached to the pulley, and the block sitting on the cable is mass 2. And what we want to do is we want to study this system to understand what's going on. So in order to do this, and we'll assume that this is frictionless. We'll assume that this surface is frictionless. So what we want to do is we want to study what's going to go on in our system. So to do that, what we're going to do is we're going to sum the forces separately on block 1 and then block 2. So let's take a look at the forces on block 1 first. So the forces here, we have the force of tension pulling it up, and we have the force of gravity pulling it down. And then on this block, that's all that's acting on this block. On this block, you have the force of gravity pulling down. You have the force of the normal there, and you have the force of the tension in the string pulling it this way. Now it turns out that because when we have this string couples the blocks and makes them a combined system. And so because that string couples the blocks together, what we need to do in order to analyze how it's moving is you can think of it this way. This is block 2 here, and there's a string attached. This is block 1. Now the force of gravity, even though we have to mentally rotate this picture, so that the force of gravity is causing this block to want to move downwards. And then there's a force of tension pulling it this way. And so what you can think about is the force of gravity is trying to pull it to the right, and the tension is pulling it to the left. So in our combined weird system of thinking of it this way, we're going to call to the right positive and to the left negative. So when we're using a pulley system like this, we count just general motion. So in this case, the motion to the right with gravity. So gravity wants to pull this thing down, and we're going to call down to the right. So this down motion here, we're going to call positive motion. And we'll call any motion to the left in our system negative. So when we're looking at summing, this is a special case for this string over the pulley like this case when we're attaching it. So when we sum the forces on, let's say, block 1, let's look at block 1, that mass point how you do it. We only have forces acting, you can look at it to the right or to the left, however you want to look at it. When we sum the forces on there, we have mass 1 times some acceleration. And what we do is we say that F2 minus the force of tension equals mass 1 times its acceleration. Now just like if we look at the forward tension between two blocks, the tension that occurs here has to be the same tension that occurs up here on block 2 because of Newton's third law. So what we need to do now is we need to look at the forces on block 2. And what block 2 tells us is we're counting the force of tension on this side is positive. This block is experiencing a tension force this way, and nothing is holding it back that way. So if we sum the forces on block 2, that's equal to m2 times the acceleration. And so in this case, the force of tension is equal to m2a. So this tension force wants to pull the block in the positive direction. So this force of the tension has to be the same as that force of the tension. So we can substitute this into there, and we get that the force of gravity minus m2a equals m1 So when we want to know what the acceleration of our system is going to be, what we can do is we can move this over, and we're going to work up, and Fg equals m1a plus m2a. And so when we have m1a plus m2a, the force of gravity is going to equal a times m1 plus m2. So when we want to find the acceleration of our combined system, a, and in this case, Fg is related to block 1, so it's just the mass of block 1 times gravity divided by m1 plus m2. So the block will accelerate downward, and it will. So this is the force of the pull downward is m1g, but the acceleration isn't as large because you have to also pull block 2 with it. And so the idea is that the acceleration is a little bit lower because it's got this other mass attached that's part of the mass of the system because it's connected by the string. But this would be the idea is if you took a mass and set one on a table and over a pulley you attach another mass, and when you neglect friction, the block would experience, the system would move, both blocks would move together with this acceleration because they act as a combined system. And we get there by summing the forces on block 1, summing the forces on block 2, realizing that the tension is the same on block 1 and 2 because of Newton's third law. We then come in and substitute up here to get to calculate the acceleration, which we find out from I'm solving for A, and it comes out for m1g, the block that's free falling, and then divide by the total mass of the system.